Good morning, children. Today we are going to see a new chapter in physics, chapter 15, light. So, this chapter we have already seen the basics in grade 6. So, first let us recall that. The properties of light. Why do we need light? It helps us to see the beautiful things, the beautiful world around us. We are able to see the objects around us only in the presence of light by reflection of light. During night, there is no light and we cannot see the objects. So in that case, we prefer for artificial sources of light like tube light, candles. Yes? So without light, we cannot see anything. The light has various properties. The first property of light is it always travels in straight line. This property is called rectilinear propagation of light. So how do we know that light always take the path of straight line? Here is an activity to explain it. This is a candle, okay? So you are going to view the candle through a straight pipe. So the pipe has two ends, two open ends. So one end you will see through the pipe and the other end is the candle, a lightened candle, okay? The candle is lighted. So if I wanted to see the candle through the other end of the pipe, will it be visible to me? Will the candle be visible to me? Yes, because the light of the candle passes straight through the straight pipe and reaches the eye. Whereas in the second case, this is A case and this is B case. In B case, instead of a straight pipe, I am using a bent pipe. So will I be now able to see the candle? No. Why? Because the light takes the path of a straight line. The light of the candle will pass through the pipe like this, and since it is bent, it cannot reach the other end where the eyepiece is present. Okay, so you always keep in your mind that the light always travel through a straight line. If in case of a bent or a broken pipe, the light of the candle will not reach. So this is the best example which tells us about the rectilinear propagation of light. Then the speed of light is 3 into 10 power 8 meter per second. This we know already. So what is this speed of light? It is a constant value. The speed of light is always denoted by the letter capital small c. 3 into 10 power 8 meter per second. This is the speed of light through the vacuum condition. Okay? So this is the highest, the maximum speed of light in which it can travel is found to be 3 into 10 power 8 meter per second. And light can travel through all the medium, whether it is a solid or a liquid or a gas or even through vacuum condition. What is vacuum? Vacuum means absence of air. Okay? So even in the vacuum condition, light can pass through. Beam of light. Okay, so the beam of light is represented by a group of rays. Ray of light means single arrow mark. So this is how we draw the light rays. So these all already we have learnt. Then we have learnt about the lateral inversion. That is, when we stand in front of the mirror, our right hand appears as left and left hand appears as right. Yes or no? So this change, that right as left and left as right, is a property of light rays reflected by the mirror. This property is called lateral inversion. So how does the letters will be looking when we show it as a mirror? In the mirror, A as an inverted one, B like this, C like this, or any other letters we show it in the mirror, its mirror image would be laterally inverted. Yes, so mirror is the reflecting surface which reflects the letters or an object shown on it, and the image would be laterally inverted. So mirror is a reflecting surface, right? We draw the reflecting surface and represent it like this. I cannot bring a mirror and keep it here on my notebook. So we need to represent the reflecting surfaces by a straight line with the backslashes like this. It means this side is the reflecting surface and this is the non-reflecting surface. The plain one is the reflecting surface on which the light will come and hit. Now let us see about the reflection property of light. How reflection happens. This is a mirror. Okay, we represent it usually like this. So this side is the reflecting surface and the back side is the non-reflecting surface. Yes or no? Usually the mirror has the front side as a plain and smooth one, and the opposite side, that is the back side, would be a kind of a paper wrapped or a wood. Okay. So here, when a ray falls on the mirror, a ray of light which falls on the mirror is called incident ray, and I have denoted it as small I. When the incident ray falls on the mirror, it gets reflected back and moves in the opposite direction. Reflection means bounces back. Incident ray is in this direction, it moves towards the mirror, whereas the reflected ray comes away from the mirror. So that is the meaning, bounces back. This is called as reflection. Okay? So the reflected ray is denoted as small r. Incident ray is denoted as small I. When I draw a straight line perpendicular to the reflecting surface, it bisects the incident ray and reflected ray at equal angles. That is called your normal. Okay, normal is nothing but a straight line drawn perpendicular. Perpendicular means 90 degree to your reflecting surface. When I draw a straight line at a perpendicular degree to the mirror, it is found that that line bisects both the incident ray and reflected ray at equal angles. Okay, so the normal bisects the incident ray and reflected ray at equal angles. Now, if I wanted to measure the angle at which the incident ray falls on the mirror, I will usually measure it between the ray and normal. Okay, you have to find the angle between the incident ray and the normal only. If you take the angle between the incident ray and the reflecting surface, it is wrong. Okay, then what is the use of normal here? The normal is drawn perpendicular to the reflecting surface for measuring the angle of incidence and angle of reflection. So angle I means angle of incidence, angle R means angle of reflection. Clear? Okay. There are two laws of reflection. The two laws of reflection tells us that angle I is equal to angle R. That is, angle of incidence is always equal to angle of reflection. Okay. So, see here in this The normal is a bisecting line. If I measure the angle of incidence and angle of R, it would always be the same, because we know that normal itself actually bisecting the incident ray and reflected ray at equal angles. Then if I measure them separately, it is going to be the same again, right? So example, if the angle of incidence is 45 degree, and if you ask you about what is the angle of reflection, what would be the answer? It is also 45 degree by the law of reflection. Understood? Then the second law of reflection is incident ray, normal ray and the reflected ray all lies on the same plane. Okay, the incident ray, reflected ray and the normal ray, all these rays are lying on the same plane. They did not move away or near to the reflecting surface. They are lying on the same plane. This is the second law of reflection. There are two types of reflection. This is a reflecting surface, and if the incident ray and the reflected ray are bisected equally by the normal, and if they prove the angle laws of reflection, then it is regular reflection. So what is the law of reflection? Angle I is equal to angle R. If that is proved, then it is a regular reflection. See this. Does the law of reflection, that is angle I is equal to angle R, is proved in this case? Let us see. So this is an incident ray, this is the reflected ray of it. I am drawing a normal and I am measuring the angles. It is not the same, they are varied. So this type of reflection is called irregular reflection. Moreover, look at the reflecting medium, that is a reflecting surface. It is also not a plane or a smooth or a straight one. It is itself an irregular one. So the light ray falling on it will also be reflected irregularly. Understood? So these are the two types of reflection, regular reflection and irregular reflection. Yes, so by now we understood that mirror is a reflecting surface. There are two types of mirror, plane mirror and spherical mirror. Plane mirror is a mirror in which we daily stand in front and dress up. The mirrors which we use in our homes are plane mirror. Why it is called plane mirror? Because its front surface is smooth and straight and a plane surface. So the name is plane mirror. The spherical mirrors are not straight, they are curved. Okay, so in this chapter we would be discussing about the uses of plane mirror and the uses of spherical mirrors, where are the applications of it, everything would be discussed. So the spherical mirrors means they are curved, whereas plane mirrors means they are smooth and straight. The mirror which we use in our homes for dressing up is the plane mirror. Spherical mirrors are of two types, concave mirror and convex mirror. That we can see the later. Today we are going to discuss about plane mirror only. Right. So consider this as a mirror. For example, you are standing in front of the mirror, or any object you have kept in front of the mirror. Its image is seen on it. Yes or no? So you first clearly understand about which is the object and which is the image. So the one which stands in front of the mirror is the object. If you stand in front of the mirror, you are the object. If you keep a table in front of the mirror, the table is the object. And the one which is displayed or which is viewed on the mirror, I repeat again, which is viewed on the mirror is the image obtained by reflection of the object. Clear? So the object is the one which stands in front of it, and image is the one which is obtained on the mirror by the reflection of light. The images obtained is usually of two types, real image and virtual image. Real image means the image obtained can be seen on the screen. After reflection of light, the image can be obtained on the screen. Like the example is your projectors, cinema screen, or real images. Yes or no? So in the cinema hall, you would see the light ray coming from the back on a projector, and it is caught up on the large screen in front of you, and the images are played as the movie. So that is an example of real image, where the light, that is a reflected light, is caught up on the screen. Virtual image, virtual means imaginary. Okay, it is not real. There is no such a kind of thing exists actually. That is the meaning of imaginary. Okay, virtual image is the example of your mirror images. When we stand in front of the mirror, exact image of me is visible, but it is not a real one. I cannot capture it, but I can only view it. So this is an imaginary image. Okay, so this is the two types of images, real image and virtual image. Real images means the images can be obtained on the screen, whereas the virtual images means it cannot be obtained on the screen. It is just one imaginary one which can be only viewed. Okay. So to understand better, let us take our mirror image itself. So do you want to see the real image means, is it possible for you to caught up this image visible on the mirror on a screen placed near to it? Not possible, right? Your image would be visible only on the mirror, not on the screen placed near to it. That is why it is called that all the mirror images are virtual images. They are just the imaginary one which can be only seen but not obtained on the screen. Okay? So here we have the few characteristics of the image formed by the plane mirror. That is the image formed by the mirror which we see daily for dressing up. How does it look? An erect image. Erect image means straight image. When you stand in front of the mirror, a straight image of you is displayed, is seen. Is your image shaking, or it is too long or too short? No. If I stand straight, a straight image is obtained. If I stand in a dancing pose, then the same kind of a dancing pose image is visible. Okay, so in a plane mirror, the image obtained is an erect, and a virtual image, this we already discussed, and laterally inverted image, this also we already discussed. Right? So the image obtained by the plane mirror is always a straight, upright and an erect one, and it is an imaginary or virtual image and a laterally inverted image. Okay, so that is why we have seen that in the emergency ambulance van, in front of the van the letter ambulance would be inverted and written. Okay, so that the person who is going in front, the person who is moving in the front vehicle would view through the side mirrors. If you are going in a car or a bike, you would look through the side mirrors, right? So that if an ambulance is coming back of your vehicle, the inverted images would be clearly visible to you as ambulance, and you would leave way for the vehicle to go front. Understood? So in a plane mirror, the images are always laterally inverted. The next is distance between object and mirror is equal to the distance between image and mirror. This is a very important point. Look at here, this is the mirror and this is the object. So the distance between the object and the mirror is, example, 2 meters in the sense The same would be the distance of the mirror and the image. If you're standing at the end wall of your room, and if you kept the mirror at a distance of 1 meter in front of you, the same kind of distance would also be seen in the image formed on the mirror. There is no variations. The mirror image will not be looking like as if you are standing near to the mirror or as if you are standing very far to the mirror. The same distance will be shown in the image also. Okay, so that is one characteristics of the plane mirror image. And the next is the size of the object is equal to size of the image. See, if this size is about 1.5 meter means this is the object. The image size also will be 1.5 only. It will not show you as too tall or too short. That kind of mirrors is also present, but we are discussing only about the plane mirror. So, in the plane mirror, the size of the object is equal to size of the image obtained. And the distance between the object and mirror is equal to the distance between the image and mirror. Okay? So, with this, I would like to stop. Kindly recall the concept start once again. And if you have any doubt, contact me children. Thank you.